You know what happened on this day in history. Open a drawer in your kitchen. It is in there. 113 years ago today, in a furnace in Sheffield, a man poured a steel that would not rust. He was trying to make something else, and he failed. He was not the first either. Two Germans had patented one 10 months before him. An American in Indiana had been melting his own for 2 years. None of the three knew the others existed. All three were right. Only one of them ended up with a word. Start with the boy washing bottles. Harry Brearley was the eighth child of a Sheffield steelworker. The family lived in a house about 12 feet square. In that city, in that decade, your father's trade was your trade, and the trade was steel. He left school at 12 and went into Thomas Firth and Sons as a laborer, which is to say he was sent to carry things on a furnace floor. He was too frail for it. Within weeks, they moved him out of the heat and into the chemical laboratory to wash the glassware. That is the whole of his education. A boy at a sink, at the back of a room where men in collars tested steel and wrote down what they found. The chief chemist noticed him and started handing him mathematics books. Not lessons. Books to fill the time between the bottles. He read them. Then he read the ones after those. He taught himself the science of the material his city was built on. He did it standing at the wrong end of the bench. By the time anybody thought to give him a title, he had been doing the work for years. 29 years after the sink, he was running a research laboratory. In 1912, the British Army came to him with a problem. Rifle barrels wear out. Fire enough rounds and the hot gas scours the inside of the barrel. The rifling goes soft. The gun stops shooting straight. The Army wanted a steel that could stand being fired through. So Brearley started melting alloys with chromium in them. One after another, month after month. Each one cast, cooled, cut, tested. Each one not it. On the 13th of August, 1913, he poured another. 12.8% chromium, a quarter of 1% carbon. That pour is the date. That is why this is the day. Everything else in this story is either before it or because of it. It did not fix the barrels either. What happened next is the part worth slowing down for, because he did not discover it. He failed to look at it. Here is how you read a piece of steel. You cut a slice, you polish the face until it is a mirror, then you etch it, you put acid on the surface, and you wait. The acid eats the boundaries between the grains faster than it eats the grains themselves. The structure of the metal rises out of the surface. Now you can see it under a microscope. Every metallurgist alive did this every day. It is how you find out what you have made. Brearley polished his slice, put the acid on, and waited. Nothing came up. He tried a stronger reagent. Nothing came up. He tried the acids you use when the ordinary ones fail. The surface stayed a mirror. He had been asked for a metal that could survive being shot through. What he had made was a metal he could not see inside. The failure was the finding. It took a while for anyone, including him, to turn it round and say it the other way. This steel does not corrode, so he took it to the trade. Sheffield had been putting an edge on steel for 300 years. Brearley sent samples to two of its cutlers, George Iberson and James Dixon, and waited. The verdict took months, and when it came, it was total. The steel would not forge. It would not grind. It would not harden properly. It would not take a polish. And it would not hold an edge. Iberson wrote back that in his opinion, this steel was unsuited for cutlery steel. 5 tests, 5 failures, from the people who knew more about knives than anyone on earth. Essen, Germany, 10 months earlier. At Friedrich Krupp, 2 men had been on the same problem for 4 years, and they were not thinking about knives at all. A physicist named Benno Strauss and his assistant, Eduard Maurer. What Germany was building in those years was high-pressure chemistry. Vessels that hold gases at pressures nobody had contained before, at temperatures nobody had sustained, full of substances that eat ordinary steel from the inside. That is the industry that learned to pull fertilizer out of the air. It could not exist until somebody built a tank the process would not eat. Strauss and Maurer were not looking for a metal that resisted rust. Rust was the least of it. They were looking for a metal that resisted everything. On the 17th of October, 1912, they filed a patent. 18% chromium, 8% nickel. Metallurgists still call that 18-8. You know it by its other name, Type 304. It is the stainless steel most of the world is made of, and it was patented 10 months before the pour in Sheffield. Then they named it. Or rather, they did not. They gave it the next line in the laboratory notebook. V2A. Versuchsschmelze 2, Austenit. Experimental melt number 2, Austenetic. That is not a name. That is a filing system. And it worked because of who it was for. By the middle of 1914, 18 tons of experimental melt number 2 had gone out of Essen to the chemical works at Ludwigshafen. The men ordering it did not need a word. They had a specification number. A specification number is what you write on a purchase order. Krupp had the stronger alloy. Krupp had the earlier patent. Krupp had a paying industrial customer before Sheffield had a single knife. What Krupp did not have was a word that anyone outside a laboratory would ever say out loud. Back in Sheffield, Brearley had a steel that 5 expert judgments said was useless. The cutlers had 2 objections, and the first one was fair. The metal was hard. It fought the grinding wheel. 300 years of accumulated muscle memory did not apply to it. Everything the trade knew about making a knife had been learned on a different material. The second objection was not technical at all. A knife that does not stain is a knife a household stops polishing. Sheffield sold cutlery to families who cleaned it every week. They replaced it when it wore out and pitted and went dull. Take away the staining and you take away the ritual. Take away the ritual and eventually you take away the replacement. The trade was not confused about the product. The trade understood the product completely. That is why it did not want it. So in June 1914, Brearley went round the trade to a man he had been at school with. They had sat under the same headmaster, Ernest Stewart, cutlery manager at Robert F. Mosley, at Portland Works. Stewart did not believe him. A steel that did not rust was, on the face of it, unlikely. But he also thought that if it did exist, it would be worth the trouble of finding out. That second thought is the reason you have a fork. He spent 3 weeks on the hardening. Everyone before him had used the heat treatment for ordinary carbon steel. On this metal that produced a blade which would not take an edge, Stewart worked out what temperature it actually wanted, which was not the temperature anybody assumed. Then he ran the test that decided everything, and no laboratory on Earth would have run it. He put a blade in vinegar. Not acid at a known concentration, not a reagent from a bottle with a label. Vinegar, because vinegar is what a knife actually meets. A knife does not live in a laboratory. It lives next to salt and lemon and vinegar and gets left wet on a board. He left it there. He came back. The line that comes down to us is what he said next. Not that the steel was proof against corrosion. Not that it was rustless, which was the word Brearley had been using and the word that would have gone on the invoice. What Stewart said was that this steel stains less. Stains less. Stainless. The word that the entire world has used for 113 years is a comparative. It is not a claim that the metal cannot corrode. It can. Stewart knew it could. He had just spent an afternoon over a jar of vinegar finding out how much. It is a claim that it corrodes less than what you had before. That same year in Essen, a clerk was writing experimental melt number 2 onto a purchase order for 18 tons of it. 2 rooms, the same 12 months. Near enough the same idea about chromium. In one of them, the material got an index entry because the customer was a chemical works and a chemical works orders by number. In the other, it got 2 words because the customer was a household with a drawer of knives. Only one of those travels. The first knives came out of Portland Works that same year. Brearley left the Firth laboratories not long after. The argument was over who owned the patent. The patents went the way patents go. An American in Indiana named Elwood Haynes had filed before Brearley and been refused and was winning his appeal. So the English side bought him off. 30% of a company they incorporated 3 weeks before the ruling was due. They divided it rather than find out. In 1923, a court looked at the 2 patents side by side and declared them both valid. Both. The legal answer to who invented stainless steel is yes. Krupp's steel went into chemical plant and pressure vessels and eventually into everything under the name Neurosta. Brearley got the credit and a plaque and an argument with his employer that cost him his laboratory. And the word that got out of the trade and into the language was the one from the vinegar jar. So who invented it? At least 10 people made this steel before any of them. Half a dozen wrote it down. Being first was never the scarce thing. Brearley was not the best metallurgist in this story. Strauss and Maurer had the stronger alloy, the earlier patent, and the paying customer 10 months ahead of him. What Sheffield had was a friend from school who did not believe him. 3 weeks of stubbornness at a hardening furnace, a jar of vinegar, and 2 words an ordinary person would say. The steel was invented 3 times. It was named once. 113 years ago today, in a furnace in Sheffield, a man failed to solve the problem he had been given. Then he could not see inside what he had made instead. The fork in your kitchen drawer is what that failure turned into. Nobody polishes it. That was the objection.